All right, so we are live. Hello, everyone. Thank you for watching this video. So I'll sort of make this like a YouTube introduction. So I haven't done for last two
All right,
videos.
so we are
For
live.
this one,
Hello
just a second.
everyone, thank you for watching this video.
So what I did here is I played a YouTube video and then my voice is echoing. Sorry about that. Okay, so welcome everyone. So in this session we have Akshay P.K. So we're not just doing alumni sessions, we're also inviting industry experts to share some talks, insights to all of the students. So specifically, why Akshay? So I sort of, for a brief time, Akshay and I worked in the same company. That's where I met him. And then he's one of the folks who keeps inspiring me on a day-to-day basis. Right, so now I used to do a lot of things for the student community, and then when I saw Akshay, I was like, okay, so there is more we can do. You don't have to just hide back in the shadows and try. You can just come out, push on a bigger level, and make bigger changes. And that's how I got to know Akshay. But an interesting story from my side about Akshay is he moved to another company and then he moved to Netherlands. For anyone who's not aware of what or where Netherlands is, sort of a country in Europe. So he's working there, and something that I always envy about Akshay is, as part of work, he travels across all the countries in Europe. Every week I see him in some country and then some post, and then I see him buying gadgets, different other stuffs, and I'm like, okay, great life, right? So I always feel Akshay is enjoying his life, nice. But then when we look back into it, Akshay has put a lot of effort into learning, doing hands-on, and all these things. And he's someone who can give very good practical advice on cloud. And I don't want to talk too much because I might steal some of his light if I do that. But then, so the reason why I told all of this fancy stuff where he's working, the fancy things he's purchasing, the cool lifestyle that he has is, so all of that is not like a cakewalk for him. From our conversations, he had his fair share of struggles, challenges that he went through. He went to the next step, and then spent a lot of efforts. And one statement that Akshay told me, which I use as my own statement even to this day, is one topic a day, 365 topics a year when you're learning things. This is what I tell people and I tell myself. And some of you who spoke with me, you might have heard me telling this. So that is something I copied from Akshay. And Akshay is currently working as a lead principal systems engineer. So, I mean, I cannot walk you through whole designation chat, but to simply put, he is way above or equivalent to somewhere around manager or architect, somewhere there. So it's a very high position in the field of cloud and DevOps. So with this, I'll stop blabbering, and because I'm blabbering this much, I'm too excited to have him here. And I hope you all leverage this. So Akshay will share his insights and all that, and at the end we can also have a Q&A. So Akshay.
Thanks a lot, Shrikant. It's been quite a few years since we first spoke. But before I get started, I would probably first wish everyone a very happy Diwali and to all of your families, and to have a happy and safe Diwali. You will probably hear a few crackers on the side in the next few minutes. But I'm very happy to be here, very happy to share some of my knowledge with all of you, because we have a different set of years, people from the first year to the final year of college. I'll try to ensure that I keep uh, my talk on point, and you can feel free to disrupt me anytime that you want and ask for any questions that you feel like. But the last 8 years of my industry experience has been a humbling experience. I always try to practice humility. I try to inspire a lot of people throughout my journey, And I hope by the end of my talk today, you all get a bit of inspiration and you also start your journey if you choose in the space of cloud and DevOps. Shrikant, back to you.
Oh no, the stage is all yours. However, you
Okay.
want to take it, so
Okay.
you can please. Next 1.5 hour is fully yours. So 1 hour will just let you share all your inputs. Definitely will stop you in the middle. So we
Okay.
have so many active folks in the session. We have roughly around 30 people, and I still see others joining, and I
Cool.
see another 20 on YouTube live stream,
Okay.
and it keeps increasing. So yeah, please.
That's wonderful. Okay. Probably before I get into some of the topics that I wanted to cover today, and I have a nice presentation for you guys with some nice animations. Thanks to Canva and to generative AI for giving me all of the content. But before that, I'll share a bit about my experience. I graduated out of college in 2017. So I studied in a tier 3 college, even though my schooling was really good. I did not get that many marks compared to that of my brothers and all that. Those guys were amazing. I used to look up to them for anything and everything. And at one point in time, I tried to change my life a little bit by following certain principles, out of which Srikanth mentioned a very nice one, which is one concept today, 365 concepts for the entire year. So that's what I always tried to follow. I always tried to learn something new every single day. And that started after I graduated out of college. So by the time that I was in my first organization, I used to work at night shifts. I used to take interviews for US candidates because that was their business model. And during that time, I realized that I probably wouldn't go anywhere if I continued to do that same stuff every single day for 2.5 years. So that's when I decided, why not? Let's try something different. Let's try to go to the office around 2 p.m. in the afternoon, even though it was on night shifts, right? And sit and study for 4 hours every single day on certain technology aspects, starting all the way from core Java and then going towards the journey of cloud, uh, learning a bit of AWS, learning a bit of Azure, and all of those concepts. And by the time that I reached 2.5 years or 3 years of experience, I was already able to crack a few companies in the space of cloud and DevOps and get my first real practical experience and opportunity in the market. So, what do you learn from that experience is that if you just put your head straight on achieving something, if you really badly want it, if you really want to transform your life, if you want to go to the next level, all you have to do is spend the right amount of time and you have to do a lot of hard work. You have to invest a bit of money that you earn back into your education, and that would take you to the next level. And what I ended up doing as part of the journey is also write quite a few certifications. I saw Srikanth in one of the previous lives, you had a very nice question about certifications. My take on certifications has always been that you use it as a step to validate your knowledge. So I had a secret 7 step routine towards cracking any certifications. And I'll share that with you guys today because most of you would probably step foot into the industry and most of you would probably hear about certain certifications on the cloud from Amazon Web Services or Microsoft Azure or Google Cloud Platform, and also certifications related to certain programming languages, certifications related to networking, certifications related to data engineering, and so on. And my secret 7 steps has always been one, choose a really good course. And then you could probably ask back a question. There are plenty of courses out there. Which one do I choose? Choose the one that has really good ratings. Choose the one that's updated. That's always been my stance. And then do the practicals from the course. Do the practicals from the back of your mind. That's the third step. And then the fourth step I used to follow is to read through certain FAQs, read through the documentation, refresh your knowledge. And then the fifth step that I used to follow is to write a lot of practice tests. And then the sixth was my secret step ever. 2 days before the exam, 2 days before writing a certification exam, you go through all of the materials that you just went through, but note down only the key bullet points that you really want to remember. And then the last step would be to just actually go out, write your exam, do all of the practice tests before that. I used to do this for the practice test. Do practice test one, two, and then one, two, and three, and then one, two, and three, and four. And then you go in that same order that you have already done the first practice test 10 times. So the more amount of questions that you end up remembering, the better it is for when you write a certification exam. But the maximum weightage in today's world compared to that of writing a certification exam is the practicality of it. So, throughout my entire experience in the industry, I have been extremely fortunate, extremely blessed to have met some really amazing people in the market. And some of them are really my close friends, even till date, people who are my college juniors, a person called Sri Balaji and a person called Sriram. These guys are people whom I look up to right now and from whom I learn, whereas at one point I was able to teach them something. Right? So these people have taught me that practical experience matters a lot more than certifications in today's world. Because when I was in 2017 writing all these exams, maybe there were that not that many people that were certified. But in 2025, we are in the age of AI and all that innovation that you get more weightage towards your practical experience. So do more projects, build more applications, create more architectures. That's my final advice. So following this throughout my entire journey helped quite a lot. I did around 16 certifications, but no one knew that I failed at least 10 of them. And every time it was an investment from my side. So I used to reinvest my salary towards my education at the starting period of my career. And that set the stage for the rest of the 6, 7 years. Yeah, I just wanted to share that journey with you. Maybe you would find something really inspiring out of it and you would do the same for yourself. If you do get to a really good stage, like myself or like Shrikant, then there's so much more to learn and grow. My only advice is to also give back that knowledge to the community, right? So you could be a starting point for inspiring so many others to step foot into this world of IT. So having said that, I'll probably go into my presentation and the topic that I have for today. It's a story that I haven't told before, not in this particular way, not in the content that I have prepared. And I hope it's really in layman terms that you would all be able to understand, and people who are watching on YouTube Live would also be able to understand if they are not from an IT background. So I'll go straight away into the presentation and I'll share certain really nice aspects with you. And the story that you haven't heard in regards to cloud computing, you would have probably studied some of this when you are working, sorry, when you are in your third year of college or second year of college. Maybe some of your final years who are on the call would know a bit about this. But I'll put my own twist onto it so that it's really nice for you to learn and understand. So now, since that we are already live, I would like to say that the booth sequence is completed and we are ready to go. It's a very nice statement when it comes to, okay. In the beginning, computing lived in vast rooms filled with blinking lights and endless hum. I think someone's annotating on the screen. Machines were so large, so rare that they felt almost mythical. Only a few minds could command them, and the rest of the world could only watch in awe. What does that mean? So back in the 1950s, there was this concept called as mainframe computing. It went all the way until 1970s, and we even still today have quite a lot of applications that runs on mainframe computing. And that's why the last statement of the first paragraph makes a lot of sense. Only a few minds could command them. Rest of the world could only watch and awe. But what happened from then is that across decades, something really extraordinary happened. Across 75 years of innovation, what began as a handful of isolated machines, it grew into a living web of intelligence. connecting continents, powering dreams, and reshaping how humanity thinks and creates and communicates. So you will see in this entire journey, in this entire story, how we went all the way from mainframe computing to what we now call as AI and edge computing and so on in 2020, all the way to 2025. So it's not just the story of technology, it's the story of how human curiosity learned to live in the cloud. So I just wanted to start this with something cinematic, you know, because we have a nice background, thanks to Canva. So as part of today's lineup, we have the Age of Giants, where we would study a bit about mainframe era and mainframe computing during the 1950s and 70s. And then we had the Age of Independence, where we had a an organization called DEC that brought out a personal device like a mini computer. And then we had the PC revolutions in the 70s and 80s. And then we went towards the client server model, which was called the client server revolution in the 1980s and 90s. And then the early 2000s, we had the age of the web, the internet revolution. And then we moved on to the age of abstraction, where literally everything was abstracted from you, and you had some really nice innovations where you could access certain services through the internet, and that's where the cloud revolution began. And 2006 was the year when Amazon Web Services released two of their amazing services, S3 and EC2, in a short span of a few months. And then 2010 was when Microsoft Azure came into existence. 2008-ish, you had Google Cloud Platform come out. So that's where the entire cloud revolution started. And then we also had the age of fluidity, is how I like to call it, just containers and microservices in the 2010s to 20s. And we are still in the microservices era, but we have also learned a bit of serverless computing, which is something that I would talk about a little bit. And then now we are in the age of intelligence, or intelligence fabric, as I like to call it, the AI and edge cloud 2020s onwards. So we are going to start as a historical lesson from the 1950s and wrap up with 2025. Let's start off with the age of giants, the mainframe era, 1950s to 70s. So the core idea with the mainframe era was that you had centralized power and shared access. So what do I mean by that is you had computing that lived in great halls of machinery. You had massive rooms filled with humming machines the size of cars. These were mainframes. They had different processor cores for different tasks. You had a you had a processor for creating something called virtual machines. You had a processor that was just dedicated towards CPU computing. You had a processor that was dedicated towards input output operations. And mainframes are even existent in today's world in certain areas and certain domains. And it's really amazing to know that even at 90% of execution power, a mainframe would still beat a virtual machine just because of the way that it was its internals were structured. It was built for resilience. It was built for scale. The scale was only scale up, and I'll tell you the difference later between scale up and scale out. And they were expensive. There were only a few, and they were sacred in the sense that organizations like IBM were the ones that ruled this era, and even today in the market, it's heavily dominated by IBM. So users didn't own their own computers. They rented them on time. There were no UI kind of interfaces. So you had only a terminal. There was just a window to a giant brain in the basement, as I like to call it. If you think about this as an analogy, think about a power plant, from where you rent electricity. Like that's the analogy that I would give for understanding a mainframe. You would only rent that electricity. What was provided is what you get, and so on. But the impact that mainframes brought into the era of cloud computing is that it talked a lot about shared resources, talked a lot about central control and remote access to a terminal. So from the mainframe era, what really happened is another concept, which was the mini computers and PC revolution, which I like to call the age of independence. And the analogy that I would give for it is the same power plant that you have. Think about you owning your own generator, and now you could power your own devices. So you don't depend on someone to provide you power. You have the power in your household itself. So that's how it's the age of independence, and it went from centralized to a decentralized architecture. So the core idea was to power the departments and people. So there were mini computers like the DEC PDP-11 that made computing smaller and cheaper. Departments could now own their own systems. Then came the personal computer. It became really personal, local, towards the individual. You could all use your own laptops today. The impact is that the pendulum swung from centralization to decentralization. Like computing fully spread out, but everyone were now managing their own systems. It's like a city full of independent power generators given to each and every household or department, and then but with maintenance headaches. So the problem with mainframes that we saw a few months before is that there was a steep learning curve when it came to uh, understanding a mainframe system. Uh, it was also extremely expensive to procure one, and there were certain languages that were used which are extremely difficult to understand and to troubleshoot and so on. Because of those disadvantages, we slowly moved towards from a centralized architecture to a decentralized architecture. Uh, so this was during the time of 1970s and 80s. And then came the client server revolution. This is how you like to, the way that you think about this is you have a server which has certain resources. It provides certain applications for you to access. And then you have the client, who are all of us, who connect to the server, and then we end up accessing all these applications. Think about it an from an household. You have a laptop, you have phone, maybe you have a television also, but all of these are connected using a concept called as local area network or LAN. And because of that, these devices could talk to each other, and that's where that revolution of client server came about in the 1980s and 90s. So the idea was sharing resources, devices, applications through networks. So as businesses grew, standalone PCs became islands. So where the client server model came into the picture, it created a new balance. Servers were the ones that stored the data and the applications, and clients were provided with very nice user interfaces, and they were all accessed through a local area network or LAN. It became the nervous system for organizations. So the impact of this is this set the stage for the internet. So as we realize that the power of connecting machines together, right, the foundation of the modern cloud was being laid, which was networked computing. So this is amazing, right? So this is how even today in your household with a Wi-Fi, you are able to connect multiple devices together. Maybe you have a movie sitting in one of your other laptops or on your server that you have in your home, and then you use your laptop to connect to that server where you have your movies, and then you can access them from your laptop. So a client server revolution. So all of this came back, let's say, 30 years before. Right? Crazy. And then came the internet revolution, 1990s to 2000s. We had the age of the web. And I would like to recollect an amazing statement which I have in the next slide. It was a statement from the company called Salesforce in 1999. They gave the term no software, and that became a revolution because Salesforce at that point in time, their entire vision, and for people who don't know Salesforce, they are a CRM based platform, customer relationship management platform. You can Google it up. But the revolution that they wanted to do was to state that they would move to a subscription based model than providing their software in CDs or in DVDs. So that was a revolutionary statement, and that set the stage for the internet revolution. So the core idea was that the world gets connected, the web exploded, any computer could talk to any other computer on earth. Companies like Amazon, Google, and Salesforce emerged, seeing the web as more than pages. It was more of a platform. We moved from creating products to then creating products, but allowing people to access them as services over the internet. And going back to my statement, Salesforce 1999 slogan was no software captured the first whisper of the cloud. Why install software locally when you can use it over the internet? This also set the stage for a pricing model which was crazy, called as the subscription based pricing model or pay as you go pricing model, where you pay for only what you use. And that's what cloud computing talks about a lot. You access a service over the internet. You end up using that service for a set amount of time, and then you pay only for that set amount of time. You don't rent servers anymore. You don't have huge machinery sitting around anymore, but it's all managed by the cloud provider. All of this came after the internet revolution. So the web itself shifted from computing from products to services. You no longer needed to own your own, own your own server, but you could just rent computing over the internet. You could rent a virtual machine of a set capacity, two virtual CPUs, 10 gigs of RAM, for example. You could rent some amount of storage over the internet. You could rent, a database over the internet, and you pay as you go in the sense you pay only for what you use. So this is where things really get interesting. And this is where they fixed a very big problem from before. If you're in your third year of college, you would read about grid computing and cluster computing and all of that. The successor of grid computing is what I like to call as cloud computing, because the entire network backbone that's set for all these data centers to be connected with each other needed to have high bandwidth, low latency network cables set up all across the globe. And, and, and when they sorted out that particular problem, that's when cloud computing became pretty big. And that's what we are going to see next. The cloud revolution, 2006 onwards, the age of abstraction. Because if you want to rent a virtual machine, someone has to procure the hardware, someone has to manage that hardware, someone has to maintain that hardware, someone has to patch and update that hardware as part of their maintenance cycles. Someone has to also provide a way for you to get virtual machines. So, which means there needs to be a layer called as a hypervisor that allows you to create virtual machines, and it's a software layer. It was you can Google up virtual machine monitors or VMMs that talks a bit about how the hypervisor functions. And then you could create your own virtual machines over a particular physical server. But someone had to maintain all of this, right? And that's where the shared responsibility model came into the picture. So a shared responsibility talks about, so there is a cloud provider, he takes care of certain tasks, and then you, as the person who's consuming that service, and remember, we went from products to services over the internet, you are consuming that service. So you are responsible for whatever you deploy onto that server, whatever you maybe you want to deploy an application onto that server. You want to handle certain networking configurations of that server. You want to store some data onto that server. So all of that became your responsibility, but providing that server, maintaining, managing the life cycle of that server, including the hypervisor layer, all of this was the cloud provider's responsibility. So that's when the cloud revolution came into the picture, and you had very big organizations. Sorry, you had very big organizations like Amazon Web Services from Amazon, Microsoft Azure from Microsoft, and Google Cloud Platform all come into existence. And in 2006, we had EC2, which is called as Elastic Cloud Compute, and S3, which is Simple Storage Service. It forever changed the game. Simple Storage Service allows you to store objects or object-based storage like a PDF, a text, a video, anything that you would like to store. EC2s were the way that you were able to procure a virtual machine by paying for it for the amount of time that it runs. And then you could install any software onto it. You could terminal access into it, which is remote access. If you have a Windows server, you could probably use remote desktop protocol and have a nice user interface through which you connect. That's the service that started the revolution. And then slowly you had other cloud platform providers come into the picture with Microsoft Azure in 2010, Google Cloud in 2008, and OpenStack. So the focus completely shifted towards virtualization, which is there is one physical machine at the end of the day, but it pretends to be many. So at this point in time, I would like to also mention a bit about virtualization. So you have two different types, as I like to call it. You have hardware level virtualization or bare metal virtualization, and then you could also talk a bit about host level or operating system level virtualization. So which one is used quite a lot in the industry? When you create virtual machines, it's mostly hardware level virtualization. You have a physical host, and the hypervisor could directly run on the physical host, and then it could create multiple virtual machines for you, and each virtual machine had its own operating system. So I could have one with Windows Server operating system. I could have one with Kali Linux as a Linux distribution. I could have one with Ubuntu. I could have one with Red Hat Enterprise Linux. These are different flavors of Linux-based operating systems, and it's all running on a single physical server. So the single physical server's entire capacity determined how you end up creating all these virtual machines, and each virtual machine's resource capacities were determined based on the total physical machine's size. So that's the hardware level virtualization. You always had the bulkiness of the operating system in each and every virtual machine that you ended up creating. But even today, you could always scale up your virtual machine from maybe 2 cores of CPU, you want to go to four, maybe from 16 gigs of RAM, you want to go to 32 gigs of RAM. You could always scale up, or you could always scale out. Like I mentioned, I would tell you the difference. Scaling up is to increasing the resources of your machine. Scaling out is when you add more machines. So scaling out is a great concept with the next revolution. When we study about it, you will know what scaling out means. But you could always do one of these two strategies depending upon your application's architecture. And computing actually became like electricity. It was invisible somewhere in the cloud. You could probably walk one day in your to your college and then probably look up. Yeah, that's probably where your servers are running. And it was scalable. Like I mentioned, you could scale up or scale out. It was everywhere. And the impact that it made on the cost aspects. And that's why most of the organizations embraced the cloud revolution. They always moved to the cloud, was because it turned capital expenditure into operational expenditure. Capital expenditure talked a lot about buying servers. Then you had some other vendor come in and set up the operating system on those servers. A different vendor come in and do all the networking for you. And then you probably had a different vendor who would install certain applications onto that server. You would have to procure licensing for all those applications. It was quite a bit of a TD task for any organization. But with the cloud revolution, you turned it into operational expenditure, which means you pay only for what you use. The most famous term is pay as you go pricing model. You could pay by the hour. You could also pay by the minute, depending on which service that you ended up using. You could also pay for the software on a monthly basis, or you could pay for it on a yearly basis with some discounts. So the entire landscape of financial um, or fintech of the cloud completely changed, or financial operations of the cloud. You turned capital expenditure into ongoing or operational expenditure. So you pay only for what you use. So I did spend quite a bit of time on this one because I really love the cloud era. I'm a 90s kid. I was born in 1995. I reached 30 years of age. I was in school when EC2 and S3 came out, but I'm extremely glad that I ended up studying all of it in 2017 uh, because that really set my career. I completely banked in on cloud computing for the last 8 years. I did, of course, branch a bit into different domains and areas to gain more exposure. And thanks to all the organizations that I worked, like I said, it's a humbling experience. But cloud was where I started, and cloud could also be where you start. Then came the age of fluidity, containers and microservices, serverless, and all those fancy terms that you end up studying. So there's this very nice LinkedIn post. Uh, Maybe you would come across it later. It talks about an organization who's looking for someone who's 15 years to 20 years experienced in Kubernetes and microservices and all that. You know, Kubernetes, 20 years of experience. No, Kubernetes came out only in 2014. That's what you would see in the next slide. So you really can't get someone with 15 years on Kubernetes, but then that's where we are. Most organizations, after the cloud era came into the picture, most organizations ended up moving towards something called containers, and then they went towards an application architecture called microservices. But before I go to the next slide, just a bit of background for you guys. Whenever you write an application, you end up having the business logic of your application. You choose a programming language, you end up coding your application, and then, of course, your application ends up having a user interface. Maybe you end up leveraging a framework like Angular and all that to build all of that nice user interface as a single page application. And then your backend or your middleware, as you like to call it, is a bunch of business logic written in Java. Let's say for simplicity's sake, Java. And then, of course, it talks to a database. That's where you store all of your data and all that. Let's consider a relational database like MySQL or a Microsoft SQL Server and all that. So that was your entire application's architecture. And then, if you bring all these two components together of the front end and your back end, and which is your business logic of how the application should function, and you couple them together, kind of, and then you keep on adding more and more business logic. It's a huge entire code base, one large code base, one single entity. We end up calling it as a monolith application or monolithic applications. And then, if suppose, for example, you then realize it's not scalable, it, it has a lot of challenges in terms of maintaining that entire code base. And I really can't have 10 to 15 cross-functional teams in my organization work on such a large code base. It's a huge headache. That's when you choose, maybe let's think about this architecture a bit different. Let's think about splitting up all of your business logic per business domain. Maybe from a fintech example, for accounts, you have a set of services. For transactions, you have a set of services. And maybe for payments, you have a set of services. And then your front end or your user interface is completely decoupled from all of this. It has its own architecture. It's running somewhere else. It's not tightly coupled. And then you could also potentially have different databases for different set of services, making it a bit more loosely coupled. That's when that architecture got coined and termed as microservices. And then came the other aspect to it. So let's say maybe there's an event, you know, uh, Maybe someone uploads a file and I want to do something. Maybe someone inserts data into a database and I want to do something. Maybe someone goes ahead and triggers a metric. For example, your CPU of your virtual machine scales over 70%, and then you want to do something based on it. So whenever there's an event X, you want to do Y. Uh, That's the era of serverless. So you have event-driven functions that run only when an event is triggered. Otherwise, it's sitting silent. You never know where it is sitting. You never know what it's doing. It's just silent somewhere. But then the moment that you trigger an event X, then your function runs. So that's the serverless era. So we will take a look at all of these different aspects. I'll get to the chat in a bit. Apologies. So the containers and microservices era, the core idea was to have cloud native design and scalability. And the beauty about that is that um, you could end up creating these containers, these microservices, and all of that, and they could run on any cloud-based platform. So you don't need to have vendor lock-in. When I say vendor lock-in, you don't need to be logged into Amazon Web Services. You don't need to be logged into Microsoft Azure. You don't need to be logged into Google Cloud Platform. You could potentially take your application, which is in a microservices-based architecture, which runs as containers, and then you could just deploy them on any cloud platform that you want. That became a standard cloud native design and scalability. And when it comes to the scalability aspects, for example, if you want to scale the entire monolithic application, which was one single large code base, you would probably have to do a copy of it. Maybe if it's running on a virtual machine, you could probably create another virtual machine, install your monolithic application onto it, and then probably put a load balancer in front of it to direct traffic to either one of them. And that's what the load balancer does primarily. But when it came to microservices, and you'll know in a few moments as to what containers are, you could just spin up another container for your microservice. Maybe you want to have 3 instances of your account service, 10 instances of your transaction service, 5 instances of your payment service. So that talks a lot about scalability. And the beauty about containers is that with virtual machines, the bulkiness was the operating system. But with containers, you only need 3 aspects. You have to tell it um, all the dependencies you need to run your code or your application, what is your code, and then how to run. All the dependencies that you need, what is your code, and how to run your code. That's all. There's no operating system that's probably involved when it comes to containers. And that's why the statement of virtual machines were great, but they were too heavy. They had the bulkiness of the operating system. They took time to scale. And that's when the industry saw something amazing, which is Docker was your first container runtime engine. And Kubernetes, at the end of the day, is a cluster or a container orchestrator. So it has the brains and the business logic of choosing where your containers run, on which host these containers should run. I'm just putting it in plain and simple terms. Developers could now ship lightweight, portable units of softwares, which were containers, and all you needed was an image. And to build an image, you need those 3 things: all the dependencies of your application, what is your application's code, how to run your application. That's all you need. Right? And then they ran everywhere. Systems became composed of microservices. And as the term suggests, they were small, independent functions, all communicating over APIs. The they used to talk to each other using HTTP uh, based APIs and verbs and so on. So you could have a microservice talking to another microservice to get some data, to post some data, to delete some data, etc., etc., etc. So the impact is that this started a cloud native architecture that you could take your containers, run them anywhere. As long as you had the image with those three things, your application would run as long as there's a container engine like Docker that's sitting in that infrastructure. Apps were distributed by design, they were scalable automatically, and they were resilient to failure. And Kubernetes itself, which was the container orchestrator that came out in 2014, became the new operating system for the cloud. And at this point in time, I have a very nice slide that talks about the analogy for you to understand monolithic, microservices, and serverless. So think about monolithic as one large code base deployed as a single unit. So it's like one big application. You manage the server on which it runs. You pay for the entire capacity. As long as the server runs 24/7, you pay for 24/7. But if you're on the cloud, you have a pay as you go pricing model, which means you pay only for what you use. And if you use it for 24/7, you pay for 24/7. Microservices were small independent services that communicated with each other via APIs. Going back to my statement, you had a bunch of microservices created, one for accounts, one for payments, one for transaction, per business domain of your application. You split it down, but then you ended up managing multiple smaller applications. You ended up managing multiple servers on top of which all your containers ran, and each container contributes to a microservice. And then you still paid for the entire capacity. And when I say the entire capacity for all the servers that you ended up creating and managing, right? And then came the serverless space where you had event driven functions that run on demand, scaling automatically without you managing any servers. And the best example for this is there is an event X and then your functions are triggered. For example, if you go to a website and then you probably end up clicking a button, let's think of that as an event. So you have triggered an event, and that's when the function is going to be like, oh, trigger the event. Okay, let me fire, let me start up, let me fire, and event driven functions that run on demand is that concept. And the cloud provider, there are certain services on um, AWS, Microsoft Azure, and Google Cloud Platform towards serverless computing. You have Lambda on AWS, Azure Functions on Microsoft Azure, and Google Cloud Functions on Google Cloud Platform. And they all work in a similar fashion. Maybe there is an API that's triggered. Let me trigger my function, start it up. There's a business logic that I have written. Let it do its job. Maybe there's an insert into my database. I want to go ahead and trigger a function. But you end up paying only for the actual usage. For as long as your function runs, you are being billed. So if your function runs for 5 minutes, you are billed only for 5 minutes. If you're, but when it came to virtual machines or servers, you ended up paying for it on a per hour basis. So this is the difference between monolithic, microservice, and serverless. It all heavily depends upon your applications architecture, the one that you choose. And then you could always choose the cloud services that complement your applications architecture. So over the last 8 years, I have learned one other lesson. The lesson that I have learned is that even though you learn all these fancy stuff from an infrastructure standpoint, a really good architecture is an architecture that complements the application. A cloud architecture can be anything. You could probably end up choosing 5 different cloud architectures for your application, but there's only one architecture out of all that that complements your application, that talks a lot about the scalability of your application, that talks a lot about the security of your application, that talks a lot about the cost aspects of your application, that talks a lot about the performance efficiency of your application. So choose an architecture when you are designing a cloud-based architecture. Choose one that complements your application on different principles of software design. And finally, we are after 2020s onwards in this age of AI and edge cloud and the age of intelligence. Let's take a look at this. So the core idea is to be smart, it's to be everywhere, but to be invisible. You know, this entire set of slides was done by a few prompts. I can share that later with you guys. But it's very nice to know that now there's a brain that's running somewhere, and that brain are AI models or large language models. It's running somewhere, and you could just prompt your way with it, do certain really nice things called as vibe coding and all that. All the fancy terms that you listened to in the last 2 years of this innovation, and the way the direction that it's going is scary, but it's also exciting. And that's where I would like to give another very nice lesson that I have learned is that is to adapt, because technology evolves. There's always a hype cycle with every technology. There's always a learning curve. Would you be able to catch up to where technology goes? Probably not, but you have to run that race. So it's not like the saying that, after college, life's a bit easy. You can always have a proper routine. You can chill. You don't have to study as much as you studied in college and all that. That's not how life works. You have to push yourself. You have to find certain interesting things to do. And people who have always reached out over the years to me, I've always told them that, try different things. Maybe try learning about computer networking, try learning about the cloud, try learning about software engineering principles, try learning about developer operations or DevOps, try learning about data engineering. And then one fine day, after 2 months or 3 months of exploration, you will figure out what suits you, what interests you, what comes easy to you. And you could end up going as deep as possible in that particular space during the starting stages of your career, building all of that vertical knowledge, and then slowly over a period of time, branching off into the horizontal. So that's another lesson that I learned before. Let's come back. So by the 2020s, the cloud evolved again from a utility to an intelligent fabric. AI models now span vast networks of data centers, weaves intelligence through the fabric of our digital world. It learns, it adapts, and it guides decisions in real time. So there are a few new frontiers. Edge computing brings the entire power of the cloud closer to your users for low latency. Every cloud platform has an offering related to edge computing. Maybe there are certain applications that really require servers that should be hosted in a very specific region like Oregon in the US or Paris in France and so on. Then you have AI driven infrastructure. There are systems that optimize themselves. There are systems that repair themselves. And then you also have the new concepts that I have been hearing about in the last 3, 4 years is sovereign and hybrid clouds. Sovereign cloud is to ensure that you have all of your data centers, all of the control, all of the compliance in a single location. For example, now the major players in the market are all US based companies. Even though they have data centers across the globe, they are majorly US based companies. But then what if suppose you had an organization that was born and brought up in the Europe, in the EU region, providing cloud services in the EU region? That's what I call as EU sovereign cloud. When it comes to hybrid clouds, there are certain customers that I've worked with in the past who have had certain data centers in the cloud. They were using Amazon Web Services or Microsoft Azure or GCP. And then they also had some of their servers on premises in a data center that they own and govern, where some of their legacy applications or middleware services run. So the concept of using both a public cloud platform as well as a private cloud platform or any flavors in a combination of this is called as hybrid cloud. The impact that the edge and AI cloud has today is that it's no longer a place. It's the foundation of a digital world. It's everywhere. It's like the air right now. It's not even the cloud. It's like the air around us. So that's where we are, and it's interesting times. So the essence that I would like you to take away from this is that over the last 75 years, we have been on a quest to making computing more powerful, more and more powerful, and more invisible. We were discussing about a colossal machine, and for people who have watched the anime, because I'm talking to this generation, if you have watched an anime called Attack on Titan, which was one of my favorite animes, it's a generational anime. You would never see another one like that, and there is a colossal human being in that. That's how I like to correlate this. It's one colossal machine in a basement to billions of devices now connected up in the sky. Cloud isn't a place anymore. It's the nervous system for our digital civilization. So the moment you had cloud computing come into the picture, you always set that as the base for building some amazing things on top of it. That's a wrap. So this is something really small that I wanted to prepare for you guys to share with you guys all of this knowledge. Let's see if we have anyone on the chat. I saw a chat message. Okay, cool.
Yeah, I
Thanks,
think
Shrikant.
at this point, we can open up for Q&A. Anyone who has questions, feel free to unmute yourself and ask your questions. And in the meanwhile, in case people are not yet asking, so I have few questions that I want to ask myself, Akshay, so we
Sure,
can
sure.
put
Yeah.
people into context. So that was a lot of terminology, because I tell or boast a bit telling people that I have a skill. When I listen to any sessions, I can become the audience type that I want to be. So if I sit like a first year student, then I'm like, what the heck is Kubernetes? What is this virtual machine? It's a no. Okay, so I'll start with simple questions, and in between, so there are people who've been consistently there from start to end. So if you have any questions right after Akshay answers, feel free to unmute and ask. So I'm filling the gap with my own questions in the meanwhile. So first question I have is, does anyone who is getting into DevOps space or cloud space, should they do coding? Will they touch coding? Because we hear, so I'm being a first year student or a second year student or any student, right? We hear from our brothers and sisters or from our seniors, get to DevOps, you don't have to code. Is that true?
It's not true. I learned it the hard way, to be very honest. So there are two ways that someone could come into the industry right now in the space of cloud and DevOps, right? A person who's from a developer background, a person from an infrastructure networking kind of a background. And the reason why infrastructure networking kind of background makes more sense is mainly because to learn a cloud-based platform, you need to learn computer networking and you also need to learn operating systems. So maybe you could start thinking that, yeah, coding is not necessary. Maybe a programming language is not that necessary. But that's for people who are coming only from an infrastructure background, people who are already working as, for example, system administrators, Linux administrators, network administrators. They all can upskill their careers by learning a cloud-based platform. But on the other end of the spectrum, you have developers who know how to code, who know a programming language, who knows system design, who knows software engineering really well. And the moment that they start learning about a cloud-based platform, it amplifies their market 10 times. That's what I have seen in the past. It adds more skill on top of what they already know, and which means they also go into the deployment space of the application that they are developing. So if a pure infrastructure engineer ends up moving to the cloud-based role, if you end up asking him, Shrikant, like, can you troubleshoot this issue on this application? He will probably say, I don't know. Or he would probably take out the logs, share it to the developer, and be like, hey, developer, can you take a look at this? But when a developer learns about the cloud, also learns about certain really good practices of a cloud-based platform, uh, there are these architectural pillars of a cloud-based platform. Let's say that a developer also knows that, and then understands which services he has to use to deploy his application that complements his application. Then he himself can go ahead and debug and troubleshoot because he knows which line of code caused which exception, right? And that's why I encourage a lot of people who are also from an infrastructure background to also learn a programming language, to also understand about a system design and software engineering principles. Like when you end up creating an application, you follow this 12-factor app or 15-factor app methodology, right? People who don't know, Google it, you will know easily what it talks about. But at the end of the day, even if you start your career from an infra background, moving to a cloud-based platform without coding, you will probably feel stuck after 5 years. That's what I've seen in the past. Or you would probably feel bored doing the same things every day because the tools and the frameworks that you work would differ from organization to organization. But then it's repeated work. So you wouldn't feel something interesting. And if you want to do something interesting, learn the application architecture side also.
To simplify or to summarize what Akshay was telling, you do need to learn coding and also in your day-to-day life. So I also see there are generally two roles in the space of cloud that are mostly prevalent. One is cloud engineer and the other one is DevOps engineer. And oftentimes people confuse both to be same. Sometimes there are organizations where people do both,
Right.
or some people, irrespective of the organization, would love to be part of both. For example, I am a cloud engineer. So what I do is I take services from AWS, Azure, GCP, wherever, and I integrate those as part of my development workflows, as part of the applications that I build. And also, I'm a bit passionate about cloud more than I think. So I dive into the DevOps part of it as well. So because of that, I also involve in how we run these applications. I'm using simple terminology called run instead of deploy. So development is you use AWS services that are there. For example, in AWS gives a chatbot service. You put it in your website and you feed it your college syllabus copy. Now you ask any question to that chatbot. Okay, can you tell me what is syllabus for this, and then it gives an answer. Now, as part of my development, I'm using a service. Very clear, right? So this is cloud engineering in simple terms now. But if you are running this website somewhere, it should be kept somewhere to be accessible to everyone, which we call hosting. So now, in simple terms, that hosting all of that also involves networking, infrastructure. Infrastructure is nothing but the hardware. So all of this comes under DevOps in simple terms. So if we expand now, there is like way too much an ocean of information in there. So now, irrespective of you being even a DevOps engineer, you write CI/CD pipeline. For example, you push your code to GitHub, automatically it should get deployed, get run in latest code on your website. For this, you will sometimes write script again. So if you use GitHub, there is something called GitHub Actions. Very traditional day-old process that many companies use to this day is Jenkins, where you write YAML files. Again, that's sort of another alternative to JSON, like a data structure format, and you write code in there, which means wherever you go in the cloud space, you will be touching some syntax, some programming or scripting. Like you need to learn shell scripting, for example. So it's not just always about know this and it is done, right? So DevOps is, or even for QA these days, I was telling in previous sessions of ours as well. This is another question I get from people. If I go to QA, do I not have to code? I can just simply go and do stuff. No, people are not doing manual testing that aggressively these days. Even there, people are writing automation testing. Yeah, but uh,
Exactly. Yeah. No, I completely agree with that, Shrikant. Yeah, you need some amount of programming language knowledge to survive in today's world, irrespective of whether you prompt it and get it, and you still need programming knowledge to understand what you're getting back from a model. So yeah, I would anyway start from the basics if
yeah.
I'm a college graduate today. Yeah.
So now that we're talking about basics, and Fanush is asking a question here. So if I'm starting in this space, sorry about that, my daughter is yelling like anything. Okay. So if I want to start in the cloud space, given that I'm a first year or a third year who does not know anything about cloud, what are the good resources online? And probably since there are students, what are the free resources online?
Yeah. It's a good question. You put me on the spot for free resources because I've always gone for low cost paid resources. Maybe I'll tell you what worked for me, and you could always look towards it. So there's this platform called Udemy, which is really nice. It has quite a lot of courses that you could purchase. And these courses are not really that costly if you choose the right author. What worked for me is an amazing author from Portugal. His name is Stefan Marek, um, and he has always given his courses on quite a lot of offers for 300, 400 rupees um, that you could buy for a lifetime. So those are authors that I would look up to, but I would always look towards a course that has good ratings and a course that has good reviews written about it. Uh, and 300, 400 should be very much possible for a college student to try and afford. I would look out for that, but at the same time, there are quite a lot of videos, official videos from official channels on YouTube itself. There are some amazing people that I have met in the past. There's a guy called Abhishek Veeramalla who's doing a great job. I only followed him on LinkedIn, and all of his courses on YouTube are as playlists. So you could always learn from really nice authors like that. But when it comes to the distinction between the cloud and DevOps space, or maybe even certain companies advertise platform engineering, all those shenanigans, at the end of the day, it all depends on the roles and responsibilities that they have written in the fine print. So whenever you are applying for jobs, final year students, look at the fine print. Don't get fascinated by the designation because every organization has their own roles and responsibilities and requirements. So look at the roles and responsibilities, but the traditional Indian mindset that I've always seen is that people don't end up asking or reaching out and asking for questions when they apply for a job. They kind of assume quite a lot of things. So if you are applying for a job and someone reaches out, ask them whatever you feel like. Ask them about how the day-to-day work life looks like. um, what does the team do on a day-to-day basis, what your responsibilities will look like. Even reach out to people, do a bit of networking, reach out to people in that organization, people who are really happy to share certain aspects of their life, and then you would get a really good clarity into what you would probably do there when you join them. And one principle I've always followed, Shrikant, is 30%. You have to do your work repeatedly in any organization that you go to if you are in the same line of work. But 70% has to be something new that you have never touched in the past, because that's what gives the growth, that's what gives the learning curve that takes you to the next level, as I call it. So look for opportunities, maybe for when you all get experienced in the market, look for opportunities that has a 70% unknown and a 30% of known, more challenges.
Yeah. So I'll pause here, and I think people are actually not getting a chance to ask questions because I'm packing the gap. So yes,
There's one question, Shrikant from Shiva Surya. He did a private message. So
okay.
yeah, so he mentioned in that question that you mentioned that I travel to certain countries. Do you see difference in the study of students or learning, or in the faculty or in the society of other countries compared to us? Um I won't be able to do justice to that answer, mainly because I have never uh, gone for higher studies. I have only uh, done a lot of certifications, but I do have friends who have done an MS in Europe and so on. But one thing that I learned from them is that if you are really looking towards doing a specialization, you should have clarity, first of all, into what specialization you want to do. And I've always seen that it's always more of a practical experience than a faculty teacher teaching you every single day for 6 to 8 hours or something like that, right? So you are probably left to you and your laptop and the internet to figure out quite a lot of stuff. And then, of course, you end up doing a thesis at the end of your master's or end of your postgraduate. But yeah, I don't know about the learning experience. I don't want to say something out of just my interest, but maybe Shrikant will have someone on the channel next to talk about that.
Probably I'll have to pick someone who actually are born in another country, so get that to get
Yeah,
that perspective. But then, Surya, here's the thing. So, irrespective of how the education or teaching is, I think the easy thing for us always to do wherever we are is to take things into our own hands. Sort of, we have YouTube, we have Udemy, like Akshay was telling. Every week you log into Udemy, one day or the other you will see a course for 300 rupees or 400 rupees. The other day it will show 5,000, 6,000, but you again log in alternative day, it shows 400 rupees. So like can purchase that course and it'll be like 28 hours worth. Stephen Marek is someone like a famous in the AWS space that everyone follows. And then there is Ryan Kroonenberg, who is also a guy from A Cloud Guru, but that's a premium website. He only has one course in Udemy. So
uh,
but yeah, that's the whole point. So now,
yeah.
yeah,
There
yeah,
are
go on.
a few people that I have followed in the past. I also started with Ryan Kroonenberg and A Cloud Guru, but I've always found that that Stephen Marek has always the updated content for AWS at least. There's one other person with whom I had only a Zoom call for 30 minutes. It was again a humbling experience. He's an excellent mentor. His name is Ranga Karanam. He has uh, uh, courses in Udemy under the name of in 28 minutes, and he also has a roadmap for Java microservices, Spring Boot, and Spring Cloud, as well as AWS, Azure, and Google Cloud Platform. It's close to 48 to 50 courses on Udemy, and on any fine day, you would probably find it for a lower cost. And if you end up buying that, I would for sure say it's an excellent investment into your professional growth. And for Microsoft Azure, I have always followed Alan Rodriguez. I try to keep it at 1.25 speed just because of the slowness which he speaks, but it's been it's been really good. Stefan Marek for AWS, Alan Rodriguez on Udemy for Azure, and Ranga Karnam for anything and everything. He's a legend.
So here's a question that that some people asked in our Discord channel. So I'm going to frame it differently.
Okay.
It's to match your line of work. So you're deploying applications, right? So or you are leading the deployments of so many applications. So in this, so do you see or like do you see any applications on mean stack, MERN stack, Java full stack, Python full stack? So is there any specific thing like, okay, Python full stack is the trend now, and those are the
Mhm.
applications you're deploying more, or MERN stack is trend, or Java full stack is trend, or it's equal depending on project or whatever that is as part of your deployment when you do that?
Okay, so from a deployment perspective, uh, I always worked with a traditional Java microservices applications, which are written in the framework of Spring with Spring Boot and Spring Cloud. Uh, that's what I do every single day for all of my customers. But more so recently, we've also been working in the AI space with agentic AI, and all these applications are written in Python with the framework of LangGraph and LangFuse. So, with these two experiences, I can always say that it really depends on what the framework can provide. Um, if it's if you require more security, if you require the robustness, if you require certain features like multi-threading, concurrency, and all of that, and, and if the framework ends up providing that based on your application's requirements of what you want to build, I've always seen more enterprises or really huge organizations that build products go towards certain, let's say, renowned frameworks like uh, microservices with Spring Boot and Spring Cloud, or I've also seen ASP.NET and MVC based applications. And more so recently with this agentic AI era, it has always been one framework that dominates the market with LangGraph and LangFuse. But from a
Yes.
deployment standpoint, I would always say, for me, nothing changes. The way
Yeah.
that you build the application changes. The
Mm.
way that you deploy stays the same. It can either go onto virtual machines on a single physical
Right.
host, you create VMs, or it could go onto containers
Mm.
as images, or it could go onto Kubernetes as pods, or it could go onto serverless with Lambda. So
Right.
you,
Also, have you seen any front-end applications like as part of your deployment? What kind of frameworks do you see on a
yeah,
regular basis?
sure. So we internally end up using Angular for all of our front end purposes. And there are different deployment models that we see for it. We were previously hosting it on simple storage service with a
Mm.
CDN, a content distribution network in front of it. And just directly building your Angular application, getting the dist directory with the apps folder with the application name, copying all of its contents into an S3 bucket. Then more so recently, because we wanted to not have a vendor lock-in and we wanted to move towards a cloud native design, which was something I spoke about in my presentation. We ended up hosting all of our front-end assets with Nginx web server. So
Now I'll tell you the original question. So the original question is, so some students were asking us, should we pick Java full stack or should we pick Mern stack or Python full stack or main stack? Right. So now which one is in the hype? So now I put that question in this manner because if in your day-to-day work basis, if you are deploying the applications which are on Java, which are on Python, which are on like Angular,
yeah,
and so on, it sends a message that see there is no one stack that dominates everything, right? So
for
just
sure.
like how we were telling, it depends on the project, it depends on the use case and the architecture. So like same as cloud, the suggestion would be pick up a programming language that piques your interest, that you're comfortable with, dive fully into it, right? So now at this point when you were in college, you're not an architect or you're not like solving all the problems of the world. You're trying to get into the space of programming, right? So at this point, do not worry too much about what is trending because there is nothing that is trending ever. There is something that is being told as trending. So
Exactly.
that's the difference. Like Akshay was talking about LangChain, so I'm sort of deviating a bit from DevOps to AML side because without touching AML, like it's a sneaky bastard that the topic comes in every other conversation. So now LangChain, LangGraph, right? So all of these things, there are alternatives as well. So if you go to AWS provides something called Strands, AWS Strands framework, And then Microsoft has its own agentic framework, the agent core that it's been releasing, updating, and so on. So now when people want to go with open source, they sort of do LangChain and all that. So now here's the thing: if people come to me and ask, is LangChain good, or AWS Trans is good, or agent core is good, then I'd say, what is your use case? Right? What does your customer use? Do they use Azure? Do they use AWS? What are the requirements? Do they want to pay for it? Now whole architecture changes. And also it's not really about what you learn too. So if you say, hey, sorry, I only learn AWS Trans, I cannot do anything else, that does not work like that, right? So they say, we don't want this, then you have to build with LangChain. Or if they say, I don't want LangChain, we work on AWS only, so we want to use exclusively AWS services. You have to do that, which means no matter what you learn, like Akshay was telling, 30, 70%. 30% is something that you know, either the concept, like how the programming works, syntax, concurrency, threading, and all that. 70% is take new use cases once you join an organization, try learning, and then solving them. So, in a gist, do not worry too much about the language or the framework that you are picking. Pick one that piques your interest and keep doing deep dive into that and keep learning there. And then you can move on later to other areas.
Totally true.
Okay, any questions? Now I'm just gonna shut up fully. People, you can unmute and ask as well. So Tejas has a question. Tejas, you can directly ask your question.
Hi, sir.
Hey, hi,
Earlier, you
Tejas.
have mentioned that you have graduated from a Tier 3 college, right, sir?
Yeah.
How did you, could you please tell me how did you get your first job, and can you give any suggestions for us as we are also from Tier 3 college?
Sure, Tejas. So the first thing that I did was, as part of my third year of college, there was a very interesting subject called computer networking in my fifth semester. So what I ended up doing is, right at that point in time, I went to my mom and I asked my mom, can I get 10,000 rupees? I want to go for a CCNA course from Cisco Certified Network Associate. And I didn't want to do the certification. I didn't have 18,000 more to do the certification. So I ended up going and just asking her to invest in my education one more time, other than my college education's bills, just for that particular course, so that I could learn it on weekends. And then I could go back to college on a Monday and I could teach it to my class. So the computer networks class was really interesting because the teacher allowed me to teach 3 units out of the 5 units, and I was able to do justice to it just because of my weekend classes. So that started my interest in the cloud space because I had a good foundation of networking. Come to my final year, I then realized that I need to also understand a programming language in quite a lot in depth, right? And that's when I banked in on the Java programming language. I learned just core Java with Java 8 and then bit of enterprise Java, building web applications with the model view controller pattern with JSP and servlets. And then I moved towards the Spring framework only after I got my first job. So just core Java and enterprise Java allowed me to create standalone and web-based applications. And that's when in my fourth year, when I started the placements for my college, because I can proudly say that I was placed initially during the starting stages itself. I had a good resume because I had CCNA course content fully completed. I also ended up going for a firewall course later during my initial stages of my final year. And then with my Java programming language, I was able to cater my profile in such a way that it's a bit more practical than more theoretical. And then my final year project, I can say that outright. Quite a few people just go out and buy final year projects. They get the entire documentation for it, and then all they have to do is just submit it and go through the Viva process. But I did something different. I built an application for my college for all of the buses with two other people, like a bus scheduling kind of application. Really simple. I just had one or two small microservices which I learned in the past in college during my free time, and then a nice user interface with JSP and servlets, where in your HTML pages itself you put in the business logic, which is Java server pages, right? And doing that for my college, I knew every single line of code. I knew how this project would also break, at which point it would break when certain features were asked. So my Viva was really easy and simple. And having built a small project, I understood how to do CRUD operations, create, read, update, delete operations to a database. I understood how to build a Java application. I did not do any hosting at that point. I just ran it out of my laptop and showed the presentation. And then building the front end aspects, two of my other friends also helped. So doing this as a small project with a group of like-minded people, and that's what I really want all of you guys to think about, is to surround yourself with like-minded people. They will uplift you when you are down, and you can uplift them when they are down. So having done this, my first job uh, was a bit easy to go through, but I what I didn't expect is life throwing a curveball at me. Yeah, I had a arrear in my seventh semester in data warehousing and data mining. And because of that standing arrear, I was not able to get a daytime job in that organization. I was pushed to work in the night shift from 6 p.m. to 3 a.m. in the morning. And if it's daylight saving in the US, it's 7 p.m. in the night to 4 a.m. in the morning. So that's when I realized that I'm going to do something completely different. But it was my first job. I wanted to join them. So then I started thinking about my career as to how I would improve myself from a technical front. And that's when I decided, let me ask the HR of the office for the keys to the office. And I would go at 1 p.m. in the afternoon, uh, open the shutter. I think she will remember, her name is Ophelia. She's a very kind human being. I would open the shutter, switch on one AC because it's hot in Chennai. You switch on one AC, you sit down, you open your laptop that the office has provided to you, and then you choose one particular course that you want to learn, and then you sit and learn it for 4 hours before your regular office hours started. Then I used to have budgie and tea in the evening before my shift started around 6 or 7 at night until 3, 4 in the morning. And I would go back home. My grandmother does very nice dosas. It's like I have only 8 years of experience in IT. She has 60 years experience in making dosas. So she does dosas. I eat the dosas. I sleep, wake up at 12, refresh, back to office at 1. No one would be there in the office. It would just be me, my laptop, and the AC running. And that's when I started learning more about the cloud and so on. So that's from my third year of college to my first year of experience.
Could you please share any suggestions for us to get into a job easily?
There's no easy route, though. uh, you need to ensure that you are unique. You need to ensure that whatever your counterparts are doing, you have to do something different. So it's not being selfish. It's being selfish in the way that you study. It's you have to share your knowledge, but you have to ensure that your profile that you're building is unique to yourself and is unique that screams Tejas. It shouldn't scream 10 people's profile, right? So that's what even I look at right now whenever I hire people in the market. And fortunately, I've been in a position to build cross-functional teams across the globe. What I see in the profile and what I see in the person is, do they have a uniqueness? Do they have an individuality? Because it's so easy to get lost in the crowd. So who are you, Tejas? Is what I want an answer for. And if you have that on your resume, then for sure, if I can see it, Srikanth can see it, any recruiter in the world can see it, and that's when you would get a really good job for yourself. Don't think about landing an offer in an MNC. Any job is fine as long as you are learning something new. As long as you get a salary that suits your needs and requirements at home and for you, and then you are learning on the job, that's a really good starting point. So it's nothing like, a 20,000 rupees salary is a good starting point, or a 1 lakh salary is a good starting point. It's the lifestyle that you choose for yourself. As long as you are happy and your parents are happy and you take good care of your family, any job is good.
I think
Thank you.
Akshay has touched a very important point. We see these days some companies are offering 1 lakh a month for freshers, and then some students reach out to me. They say, "Anna, I got a job." Like, so, and it's like 4 lakhs LPA or 5 lakhs LPA. My friend got 20 LPA. So now here's the thing. So they were originally happy when they got a job with 4 lakhs per annum, and then when one of their friends got 20, now the whole thing changed. So now they're not happy anymore that they got the job. Rather, they're like, I should have got the 20. And then so this is how the whole comparison goes, right? So even funny that we never spoke about this, Akshay, and then our story is same. Even I got an offer on campus in third year one, in final year one, and I had a backlog, and that backlog subject is data warehouse and data mining.
Oh, wow, that's nice.
At the
Yeah,
end, I had to close that
yeah.
by taking score from my project, and I don't know, there was a concept during that period in my university where you can add marks from your project and then to the subject you want. But then it can be around 6 or 8 marks, something like that. So I did that and finally got it closed. But then by the time this whole process went, the opportunity was long gone, and I had to join a startup. And this startup was by one of our alumni. Again, his name is Vidyasagar, and the organization name is In Data Analytics. So again, I got to him through one of our professors. They said, okay, he's a good guy, and then he gave a small internship, and then we got hired. And the previous speaker in the Swan Talks, he also joined along with me there. So now the point is the pay is not 20 lakhs per annum. And literally at that point, my thought process was he's torturing us. We're struggling to work. Like, is this a workplace or hell? So, and then we worked there for an year, and then it was in Vizag, and then we moved to other company at some point. To this day, I'm very happy and grateful that I joined his organization, because what I've learned after for 3 years, I've learned more than that in the first 1 year working under him, because it was stressful, but we were exploring every single thing in different directions. So now all of that knowledge and experience helped me further to get to a financial state where I want to be. So I've seen people who joined at 20 are at 23 after 5 6 years. So
Yeah.
it's not about how much you start with, it's more about how much you are learning every day. And it's the same concept we started with, right? One concept a day, 365 concepts a year. Also, it's another way of telling learn something every day. If you're not learning something new every day, then you're not in a good workplace. Like, you get into a comfort zone. Now you cannot go out, you cannot get better opportunities. Even in the same place where you are, you cannot grow. So
That's so
pay,
true.
yeah, pay end of the day is totally based on your family needs, not based on comparison with friends.
That's true. That's true. There are two things that comes to my mind. Comparison is the biggest thief. So that's one very nice statement. Everyone should take a pause, think about it. Don't ever compare yourself with anyone. And then the other one that I learned from my manager, he's from Italy. It's a very nice guy. Something that I learned from him in the last year or so is that don't concentrate on things that are not in your control. Maybe right now, as final years or first years to final years, you wouldn't realize this a lot. But when you move into a professional organization in a professional setting, there are certain decisions that are always being made at a top level. There are certain decisions that are being made without your insights or inputs. Don't worry about that. Don't care about that. the more time you spend on those decisions is time lost. So think about only about things that you can control, you can action, you can do. And that's when it comes to recruitment also, Tejas, you can only do your maximum effort into applying for a job because that's in your control. Someone to provide a job for you, they have plenty of candidates like Tejas. And that's where if you stand out in a crowd with a very amazing profile that's unique, catered to that role that you are applying for. And I would obviously say if you're applying for 10 roles, have 10 profiles, which is catered to that role. Yeah. For them to give the job is in their control. It's not in your control. So do your best, think that you have done your best, and always have a retrospective in your mind. There's always this concept of strength, weakness, opportunity, and threats. Think about it. So it's like sleep on your bed at night instead of sleeping for 10 minutes. Think about where you were, where you are right now, where you should go to. That retrospective is very nice because it gives you an, an insight into how you have performed, what skills you can learn, where you want to be. Maybe that goal for you could be monetary. Maybe that goal for you could be as small as a certification exam that you want to crack. Maybe that goal could be for you to build an amazing physique, but think about where you want to go. Uh, if you do those respective steps, plot your chart with those milestones, probably in a year, year and a half, you would reach that goal. And at that point in time, go back and watch the Matthew McConaughey's Oscar speech. He did a very nice thing over there. He told a very nice statement. He always compares himself 10 years in the future. So which means when you attain your goal, think about who Tejas would be at 30. Think about who Tejas would be at 40. Then start again doing the same thing. So I always say that DevOps is a an infinite cycle. You build software, you test software, you ship software, and then you again continue building that same software, testing and shipping. Life is also a circle. You always do the same set of things, but a bit differently, so that you end up attaining who you want to be in this world.
Okay, so we are
Thank you.
already beyond time. So what I'll do is I will invite Akshay again and another day, probably next month or later whenever he has some time for a pure Q&A session on cloud and DevOps where you can ask all the questions. And there is another option. So we have the YouTube channel where you can post all your questions as comments. And I know, and by the way, for those of you who don't know, Akshay has a YouTube channel called Tamil Cloud. And yes, he's from Tamil Nadu and he even do content creation in pure Tamil as well. So if you can understand Tamil, you can also try that out. That's a very nice content that I also follow. So why I'm telling this is you can put comments under the video, like any questions that you have. Whenever he has some free time, I'm pretty sure he will answer those questions. And this is his space, if I can put it that way. So Akshay has been in the space of giving back to the community for a long time, that too very actively. So this is not something what do we say in English? It's not his first rodeo, right? So that's why I pulled him here, and he would definitely come again if we want him to. But before that, you can ask all your questions in the comment section. Show your what do I say? Participation, your interactivity. Then probably I can ask him, right?
Yeah, and
So
maybe just one last thing is, I mean, I shouldn't take ownership for the Tamil Cloud YouTube channel. I have to give due credits to the person who started it first. His name is Suresh Kumar. We met up in one of the AWS community days that happened in Presidio. And I delivered a talk on Control Tower, which was a service at that point in time coming up. And he was the one who invited me to his channel to do certain videos. So thanks to Suresh Kumar for all the hard work that he has put in into that channel, bringing like-minded people like him to content.
Yeah, I think on that note, you also have Sri Balaji and Sri
Yeah.
Ram as well, right? On the other accounts.
Oh yeah.
So,
And I have quite a few good friends, Srikanth, and I am
definitely.
blessed to say that. Yeah.
So here's the thing, for those of you who want to learn new things, have a friend circle where you have those group of people who are interested. So when I was studying in college, so I had few friends like Aditya who joined last week, and then there is another guy called Sujan. There are a few other people. So we used to sit together, sort of fight. For example, if I learned cloud, I would talk as if I know whole cloud, and then I'm the founder of AWS, though I don't understand even a bit of it, or I sort of know high level things. And someone who learns backend or chatbots, they talk like, oh, you know cloud, I know chatbots. So there was always that friendly competitive spirit that, oh, you learned this new thing tomorrow, I learned something new and I'll show off. So it's okay to show off among your friends, that sort of competitive spirit which helps you learn. And when you have that community, it is always fun to learn. You're not alone, right? So make those friends. So group together and keep learning and reach out to people out there on LinkedIn, YouTube, different other places. But yeah, on a closing note, thank you so much, Akshay. So I don't know how it felt for third years and final years, but first years it would definitely would have been a great value because you started from the very start, and then at some point you were connecting how cloud came into picture and all that. But I wish we had more time for Q&A. But we're already like 1 hour 40 minutes. I think roughly around 2 hours already. So I don't even want to keep it so long. But again, Akshay recently came to India, and then
And
when I asked him for this talk, right?
I'm still in Chennai.
Yeah.
I'll,
So when I asked him for this talk, he immediately agreed. So that is one thing I love about him. Whenever I ask him, Akshay, we want to do this, especially if it's for students or for the community, he'll be like, definitely. The answer is always yes. Now the question would be when, right? So, and best part is he'll give you date immediately. So thank you for that, and thanks for sharing all this. And I know there is so much more that we
for
could
sure.
like learn from you and from your experience, but limited time, probably in another day. Like you said, one concept a day, so we'll digest what you shared today, and then
For sure.
again, thank you so
Thanks,
much.
Srikanth. Thanks a lot.
And lastly, so do you have any one line statement that you want to share with students?
Ah, and you're putting me on the spot. We have already spoke about one concept today, 365 for the year. But in 2025, based on what I have seen in the last few years, I would say my biggest statement is to be unique, to be individual, uh, to do a retrospective, to know who you are, where you want to be.
Nice. That's great. So be yourself. I think that's what it's boils down to, and create your own magic. Thank you all for staying until the end. And also thanks once again, Akshay. We'll
Thank
meet
you,
again.
Srikanth. Pleasure.
Have a good day.